Okay, thank you for coming. I am Manuel Sanchez. I'm going to talk about C++, QML, and static reflection. First, a bit about who I am. I am a nerd obsessed with reflection in C++ with the multiple possible implementations of reflection. I learned C++ myself during the college. And since 2016, I think I'm a member of the Spanish national body of the C++ standard. And since 2015, I'm working with access control systems. Okay. This is an overview of more or less what we are talking about here today. First, a little about why using Qt for developing applications, a little context of the project the talk is about, why using QML for your graphical interfaces, and a little process about how to port existing models to the QML graphical interface. The first of all is, okay, what's QML? QML is a declarative language to describe graphical interfaces and in a relative way. Let's say you have a set of properties of your controls or your different UI components, and you write relationships between them. And the engine automatically sends the different updates between the controls, the values, the different expressions. It's really mobile and touch-friendly. It has a lot of components centered around touch devices, buttons, drop-down lists, and stuff like that. It has a built-in theme system, like, for example, the material design from Android. You don't need to know about CSS, HTML, or something like that. It's pure QML syntax for everything. And finally, the QML system is part of the Qt framework. So since it's part of the Qt framework, why using Qt? Okay, for me, it's really about 3 different points. The first point is the framework. Okay, Qt, it's a cross-platform framework with an stable ABI, which means you can link like 5 years ago against the library and have no problems with the updates of your firmware or whatever. It has a lot of APIs, from networking to UIs, Bluetooth, whatever. In almost all cases, you don't have to rely on another external libraries. There is almost always something in the Qt framework to do your task. And finally, the runtime. Qt, it's based on a cross-platform event loop, which means from the very beginning you have an asynchronous I/O system for everything, from messaging between threads, from socket I/O, file system I/O, whatever. Everything following the same pattern of the event loop and asynchronous. Finally, the UI systems. It has different UI systems for the different use cases you could have. So you have a system for developing classical application for the desktop with widgets or whatever. Then a more declarative way, the QML, which is what we're talking about today, which is more designed to mobile applications, tablet application, automotive for the main screen of the car. And finally, it has web browsers in case you need to run directly a web page embed in your application. So some context. I have been working for 3 years, I think, on an access monitoring console. The kind of console you will see While entering an office, for example, and you call to the enter and say, okay, I am Manuel Sanchez, I have a meeting, okay, and then they let enter in, okay, and that is controlled usually with an application, or in this case with a dedicated device that controls the accesses, and it allows you to talk with video with the other person on the other side. Okay, this device is tablet-like, more or less, with a touch screen, and it's an ARM-based. Okay, the art. We have a full C++ stack UI prototype using widgets from Qt. Okay. So 3 years ago, like 1 month after I joined the company, I think, someone said, okay, let's rewrite everything using a web stack for whatever reason. Okay, I don't know why. All my alarms just popped out and say, why a web? This is a touch device with a screen. What? A web? Okay. I have nothing to say. I'm the newbie here. So the reasons were it's technically easier to get designers to work with the UI if it's a web. Okay, it's HTML, it's CSS, something normal. Okay, the development on the front end will be isolated completely from the rest of the application. So the backend nerds like me could work, while at the same time there's someone working on the front web. Technically, you could move the front from the touch device to a PC in case anyone will require that. I think after 3 years, that never happened, but it was a reason that day. And finally, it was fairly easy to do with Qt because it's just running a web server to attend the request and having a Qt with browser in your application. So it's finally the same system as before, but with a jump, that is the web server. So yeah, I have been maintaining a web application for almost 2.5 years, I think, doing more Angular JS than C++. And well, it was great, more or less. Okay, there was also backend. So the web stack was the usual web stack: a database, then a model for the business, entirely in C++, then a web API we did with protocol buffers from Google, and finally the web application itself with Angular JS, which is something I don't want to talk about more. Okay. And finally, the web data model was really similar to the usual stuff. We have a DB model with SQL, a C++ model with all the relationships, the business operation, etc. We have another model isolated from the C++ backend for the network layer to communicate with the web page. And finally, the model of the web page itself, which is whatever JavaScript does with everything. It's a map and, you know, that crazy stuff. 2 years later, the direction of the company come in and say, okay, we need more byte streams to show the byte streams in real time in the same screen, like 4 or whatever. And say, okay, we have been working with only 1 stream for 3 years. Okay, now you need another 3. Well, it was perfect. No? Yeah, it was perfect. We were completely, you know. Why? Because the device had no hardware graphics enabled. Okay, the previous web engine was running completely from software, which was okay for the case because we have literally almost no animation in the web page, so the CPU could cope with it. We tried working directly with the hardware stack of the display, okay, to try to arrange the 4 streams at the same time, and there was not possible. There was no memory in the hardware to do that. And finally, doing everything in CPU was no option whatsoever. Okay, I don't know if we finally ran a demo or something, but it didn't work at all. So what will we do now? Maybe search for another job. I don't know. Leave C++ for Java, whatever you like. I was like, okay, the work of the last 2 years is being thrown away, and well, let's see what we could do. QML. Why QML? The main reason I picked QML finally was because it has direct integration between the front and the back. In this case, the back having done in C++. Okay, so that network middle layer you have in the previous slide with the web page completely disappears. Okay, which is great because I think half the time I was writing JavaScript, another half time I was writing protocol buffer serialization manually. So if that disappears, it was perfect. As I said previously, the QML framework has a lot of widgets for mobile devices that work perfectly. Buttons, side views, lists, infinite lists that scroll, whatever you want. And finally, a great keyboard, touch keyboard that the Qt released. Okay, it's very amazing compared to that thing we have with the web page. Okay, something completely custom that someone wrote, and that was awesome from day one. QML. So another reason bad was that the hardware acceleration of QML works if your stack have that hardware acceleration enabled. So you throw the problem to the Linux freak of the team and let them fix it, and it works. Okay. And finally, for the video streams problem, QML has a component for injecting OpenGL rendering directly in the UI. Okay, it has a component that directly wraps an OpenGL rendering target. So you can take an usual OpenGL program with its loop, its rendering, callbacks, and whatever, and you put it directly in your UI. Okay. Now let's see how it looks more or less a QML5. Okay, a QML simple application, just a window. Okay. As you can see, it's very declarative. Okay, it has the name of the component and the kind of the component. Sorry, in this case, a window with a unique ID, so you can reference later that window. Some properties like the width, the height, and finally inner components that you can arrange. And this is completely hierarchical. Okay, so you have a button number named button. Okay. And an event that's clicked, okay, and that two keys, that two in the unclicked are a handler of the event. Okay, so you can simply click the button and magically something appears in the console. Okay, it's pretty straightforward. Okay, yeah, hierarchical controls, ID, etc. The key part of QML is that it implements property bindings. Okay, so the values we assigned to the different properties are not direct value assignments, are bindings between that property as a destination of the value and the evaluation of the expression to the right. Okay, so it's not static. It's not a unique segment. It's a binding between whatever the expression, because one of the operands of the expression changed, the property changed automatically. Okay. A segment is supported by the language. like the usual equal operator, but it will break existing bindings against that property, so I discourage it completely. Finally, QML does not support directly double binding, okay, like BPF from Microsoft, for example. You have to explicitly build another binding to the other side of the relationship. So they provide the binding type, which is just a way to say, okay, let's write a relationship between the field IP of the network model and put it the IP address field of that text box. Okay? Beware of binding loops. Okay, this is a problem. You have to make sure that on the value only states that it has changed when it really has changed. Okay, so and complex MVVM workflows could be really tricky to implement. Okay, but it could be done. And what about the models? The models are a problem because QML provides two options, basically, for the model. Actually, three, because it has direct model for against an SQL database, but let's see, there are only two. A pure QML app, okay, you can write everything using QML, or if you have a C++ backend, use a C++ backend against your UI. Using a C++ backend, you will have to use the Qt system of objects, that is, inheriting from Q object, using signals and slots, using Q properties, and whatever. Something like this. Okay, I have a network model object with a property IP, which is the IP address, and we have a setter and a getter, and then the variable internally. And also we have to declare a signal, okay, which is a way to tell, okay, the IP address has changed to this value. Tell whatever is subscribed to this object. I mean, a signal, it's really easy. You only have to call the method, okay? The emit word there is a pseudo keyword that Qt provides to clarify it a bit, the stuff. It's just a call to a method. And to connect to objects, you only take the object that emits the signal with the signal itself, which is the pointer to a method. Then the destination of that signal, so the object you want to subscribe that signal to. And finally, the destination slot. That is the method that will be called when the signal is fired. Okay? So we have something like this. It could work. Okay? Write all your getters, all your setters, all your properties, all your signals. But I have this. I have been 2 years doing this, not the Q property thing. So what we can do now? Reflection. Okay? I was trying to find a way to translate the usual standard C++ structs or classes or whatever into something that QML understands, okay? Something like will translate your existing models into something with Q properties and Q signals and all the stuff needed to QML to understand your model. So I use I brought actually my own reflection API for this task. Okay, the reflection API is called TinyRef. It supports, it's not tiny actually, but well, it's a bad name. Cross-building support from day one, because we are cross-building for the ARM chip. The CodeGen tool returns metadata in an abstract format, so it's not tied in any way to the API. And it provides a high-level API using C++14. The library has no external dependencies. All the stuff it needs is download by CMake and at configure time. But I am working in a Conan.io package. It's not ready yet, but I'm working on it. I have package, I think, for all the dependencies, LLVM, Clang, everything, except the package itself of the library. The tool, the CodeGen tool, is based on CPP-AST. Okay, it's a wrapper of LibClang, the IP of LibClang, that wraps all the bad stuff, I think, of LibClang itself, and gives you just a simple API of visitors that are callbacks with classes representing a C++ class, a C++ method, an attribute, whatever. The tool itself, it tries to follow a bit the interface of a Linux compiler like GCC or Clang. So you can pass directly the same flags you will pass to GCC to compile a file. Okay, but instead of passing a .cpp or whatever, you pass a header to process it and output another header, which is the generated code. The tool provides some scripts to ease the integration of the library into your CMake projects. So to use the library, you only have to add the library itself, the subdirectory building from sources of the library. Declare your library with whatever headers, sources it has, and then say, OK, I need to run the tool on my target foo. And the target foo has these headers that should be reflected, okay? And it cares of everything of running the tool under the hood and everything, okay? The tool generates API agnostic data, so you can write whatever you want by redefining the symbols the generated code uses. And finally, the API we will use for the QML stuff, it's a high-level API using constexpr and C++14. Okay? The idea of the API is that the metadata itself is represented by types. Okay? Like, for example, a class foo has a type associated with it that has static constexpr members like its name, aliases, so type defs like a list of its base classes, a list of its meta types of the static member functions, whatever you need. Okay? And at the same time, you can construct directly that meta types, so you have a more fancy object-like API. Okay? This is what it looks like more or less using the API. You have a header here with an enumeration named enum. Okay, it's pretty original. And then you include the API, and then your header, and then the generated code header. Okay? The library expects it that way. Sorry. Yeah. The library expects the headers arranged in that way because since the generated code does not depend at all on the API, it say, okay, I just have a bunch of symbols that means whatever, and that whatever is what the API does, defining the meaning. So first you have to provide the meaning of those symbols and then include that symbol from the generated code file. Okay. So, for example, to take the metadata of an enumeration type, you just call the metadata trait, okay, and ask, okay, the name of the enumeration is enum. Yeah, well, this is more or less a unit test of the library itself. Okay, you can also ask the library for the meta object of the enumeration, and the meta object has fancy methods like give me an array of the values of the enumeration, do a for loop, and print its name, its underlying value as an integer, whatever you need. Okay, it has a method in the any enum meta object, like, is this integer value a valid value of the enumeration? Stuff like that. Okay. So for a header like this, in writing from vector and string, okay, that's not very good, but it will work. It provides a visitation API. Okay, it's pretty similar to what std variant or boost variant does. Okay, but it's tag dispatch based, because depending on the stuff you want to visit, actually the type of the callback could change. Okay, it's not the same taking a base class, for example, which is a type, or a member function, which is a pointer to a member function. Okay, so the library, what it does is to take an enumeration that you can pass to the API, and this tells internally everything statically that, hey, I want only base classes. So this third argument, it will be something that points to a type. Okay? The same applies to objects. You can visit an object and say, I only want member variables. And you tell statically with that enumeration that the stuff you want to get from the object are only member variables. So the third argument is a reference to each one of the member variables of the object. So you can directly print name, the type of the member, and then the value of the member, and gives something like this. Okay. Then there is a even higher level API with utilities like visit object member variables to know how to write the enumeration and all that macro, everything put there. Okay. Then visit objects, it's an overload of the visit objects for visiting multiple objects at the same time. And then an equal generic function, a generic toString function, a generic toTuple, whatever. A lot of stuff. Okay. So going back to QML, now we have a system that we could use to do something like a for each over a type, take every member, every field we want, and pass it to the QML side. Okay. Automatically, not writing everything manually. But the problem is that Qt is still using Qt types for all its stuff, not or std types, std string, integer, whatever. So before exposing LD data, we need to translate between the Qt types and the standard types. Okay, this is fairly easy but boring. It's just, okay, let's have a trait that says from this std type there is this Qt equivalent of a type like std string and qstring, and there are multiple utilities based on that trait, like give me this string, this value string as a qstring, or give me this string coming from the Qt side and give me as an std string. Okay, so you have a layer between the QML word and your model word that is written already using standard C++ types, and you have no problem. Okay, everything is done underneath the library. Qt, since the runtime introspection system of Qt and its property system, it's completely done at runtime. Okay. So to represent values, it used a type erased type. That's called Q variant. Okay, not to be confused with std variant. It's completely the opposite thing. It's more like an std any. It's a type that it could take anything you want, and it has a tag saying, okay, I am an int. Okay, you can only read from me an int, and then change it to a bool and only read a bool. Okay. So we have a wrapper of this concept as two Q variant and from Q variant functions using the previous functionality from the to Qt from Qt layer to take different Q variants from and to values. So the idea basically of everything is that from this struct using std types, you get something like this. Okay. So we have a reflection API to do all the wiring automatically. We have a system to translate Qt types into std types and back. And now we have to tell QML, okay, here are your properties, do whatever you need with it. But the API to register new properties dynamically is not exposed to the user. It's only used by the generated code that Qt runs and generates by running the MOC tool. Okay, so it's not exposed at all. But QObject provides a dynamic property system by the means of just a couple of functions, set property, get property, that take a value and a key and gives you the value or sets the value. But QML does not support binding to that property system. So we are again thinking about LinkedIn, living in Alaska, whatever you need. Well, so that's all. Okay, thank you for coming. No. So there is a solution after, I think, 1 month of research, Googling in the Qt API or whatever. I found a solution that's a QML Property Map. It's a C++ type provided by the QML API exactly for this use case. That is, having a model in the C++ side as a set of key value pairs, okay? And that set of key value pairs is binded on both the directions. You can change a key and its value from the QML side, and your C++ side knows about the change, and at the other direction. Okay? And underneath, if you check the sources, I really recommend it. It does all the magical stuff with the Qt engine of types to create properties dynamically, registering new signals of the change of that property, everything. Okay? So this is more or less how it could look like. Okay? The QML property map is designed to be inherited from, so you can override a callback that's called whenever a key is changed from the QML side. So in your QML window, you touch a property of the object, like change the API to A, an invalid API, and the callback update value will be called. And you have the chance to change that value to something else before the value is actually saved in the map. Okay? I never do that. I just return the value that QML changed. Okay? And to the other side works exactly the same way. You have a C++ API, like a map, that says, okay, insert a pair, which case I, and a value 42. Okay? That will generate under the hood all the properties, the signals, the whatever, and the QML will see a new property named I with a value 42 integer. Okay? Then if you set the value again of the property, the QML will see it as a change of an existing property. That is, if you have a binding against that property, your left side of the binding will change following the change of the I variable. So it's perfect. It's exactly what we need for the task. So QML property map. This is a wrapper abroad around the QML property map. For the only reason, I think that extra Q has nothing to do there. So QML property map. Okay. The idea was, okay, the QML property map interface is based on Q variants, which are not type safe directly. You have some checks and whatever, but those checks are not run directly. It's not type safe at all. So I brought a little wrapper that takes templates, so the values are taken with its real type, and our library of translation between types does all the piping. Okay, checking, asserting if the type is not right, whatever it needs. But the user just sees a map interface that can take whatever you pass to it: integers, std strings, vectors, whatever you want. Finally, we are almost reaching the target of all this stuff. We have a map, a generic map, with a standard C++ interface that QML understands. Okay? So now we say, I don't want to expose directly my models to the QML because I don't want the front end of the applications to change my model whatever it wants. Okay? So I said, let's write a proxy type that takes one of these C++ models and catch it until the UI, the application, that is the user, decides to save the data. That looks something like this. It's very simple. We have two methods in the API, one method to save, okay, one method to reload the proxy, and here is that callback from the QML property map telling us that a value in the QML side has changed. The idea is take by reference one of the models, catch it in a copy. The QML will be touching the copy, that catch, doing whatever it needs to do. Okay, the user changing your IP configuration window, changing the IP address, the MAC address, the network mask, whatever. That only changes the catch. And when the user presses the OK button or accept the button or submit or whatever, the UI system, the QML system will call save, which will map everything back into the model. The model we took by reference. Okay, I brought it that way because most of the application stuff touching a model is about a wizard or a dialog changing properties like the network stuff. So reload. How we reload a proxy? Okay, just assign the catch to the value of assign the model to the catch. Okay, we copy the model into the catch, and then say, take every member of the catch and pass it to the QML property map. Okay, and since the QML property map interface is already type safe, knows about the standard types and everything, it's just a line and a for each loop over the members of the structure. Save, it's very straightforward. You have to only copy the cache you have been touching for like 10 minutes in that window and say, okay, copy that to the model. And finally, we have what happens when QML touches one of the fields of the property map. We say, okay, we only have the name of the field. We don't know about its type. We don't know about what exact member of the struct it is. But we can do a little trick that is find it by name. If you find the member, just assign it its value. Okay? So the callback from Qt passes us a Q variant with the value, and we just convert the variant to the type of the member. There is actually a typo here. This will be here a template argument with the type of the member. Okay? So this is how it could look like a hello world of an existing C++ model using standard types and a QML engine. Okay, you have your model, your network settings with an ID, which is an integer, an IP address, which is an STD string. Then you run up your QML engine and pass it the proxy to the model. Okay, and the trick is that using underneath the QML property map, which remember that proxy, it's inheriting like 1, 2, 3 layers indirectly from the QML property map. It's really a QML property map, so the Qt framework and QML understands it. And this is how your network configuration window could look like. You have the name of the window here, a text box to change the IP address. We bind the text that's shown on the IP address field to the value of the IP in the model, actually the proxy of the model. And then a binding to the other side of the application back to the backend, that says, okay, put the value of the text box in the IP field of the model. So whenever the user changes with the keyboard the text, that value will be updated in the proxy side of the backend. And finally, you have a button, and whenever that button is clicked, you tell the model, okay, save it. Okay? And now, that's all. Thank you.
Any questions?
So, not that I would disregard the work on TinyRefl, but do you think it would be possible to achieve something similar by using template metaprogramming to enumerate on members and so on?
Yeah, actually, the database model I'm using, let me go back a bit. No. Here. These classes already use our reflection system to generate the SQL queries. Okay, but reflection system is not using a library, a CalGen tool, or whatever. It's using a system of template metaprogramming that I wrote in like a weekend or so. That just takes a list of types representing each of the fields of the structure. Okay, so it's pure template metaprogramming and will do almost the same. The point of using a dedicated reflection library is that it uses a tool that scans all your code and you don't have to write anything by hand. That's the only point, but you can do manually if you write the registration of the types and the fields manually. It will work exactly the same. Any more questions? No? Okay. Thank you very much for coming.